What's going on, guys? It's your boy Zach Yoakum here. On this week's chemistry convo, we have Boron. How you doing, Boron? I'm doing pretty solid. Hey, see what you did there. We'll get to that in a second, Zach. All right, so what are we gonna start with today? Today we're gonna start with the states of matter. There's the solid, liquid, and gas states. I myself, in my prime environment, am a solid. Really, that's pretty cool. If you say so. Alright, what else you got for us? Well, all the elements are made of atoms, and atoms are made of three subatomic particles. You got the protons, which bring a positive energy to the party. Neutrons are there so that you can reach the capacity of the party. Electrons are there so that people don't get too rowdy. And we all know those party animals, protons, have to be equal to the electrons so that there's no cops or doctors that need to be around here. Alright, Boron, so how many protons do you invite to the party? Well, at my parties, I usually invite 5. But for any other elements party, you just gotta look at their atomic number. And then there'll be 5 protons, and there'll be 5 electrons. Alright, so there's the protons and electrons. What about the neutrons? Well, we do have fire codes, so you just subtract the number of protons that are going to be there from the atomic mass, and then that's going to be your number of neutrons, rounding up, of course. So at my parties, usually on Thursdays to get us through the week, I would have 5 protons, 6 neutrons, and 5 electrons at my party. You don't say. I do say. Alright, so tell me about your friendships. What kind of bonds do you have with your friends? Well, I'm a non-metal, so I can kick back and chillax with metal to create an ionic bond. But sometimes I like to chill with my own kind, other non-metals, which would be a covalent friendship. Wow. What's your favorite bond? Well, my boys, fluorine, the fluorini, we're called the boron trifluoride, BF3 for short. Wow, can I kick it? No you can't, you gotta be a fluorine. Darn. Alright, Boron, so tell me how your personal life is going. How did you come to this success? Well, Zach, you see, I, as Boron, am fairly rare. The most common way to find me is there's concentrated deposits of borax, also known as sodium 2 boron 4 oxygen 5 OH4 times 8 H2O S. So those are found in ancient lake beds, and they were used for making glass and glazing pottery. I can be produced on a large scale by reacting borax with mineral acid to produce boric acid, which is then dehydrated to the oxide. The reduction of said oxide with magnesium or sodium gives a amorphous boron that is only about 95% pure, which is an A in my book. Wow, so that's how you dedicate all your success. Yes. Alright, so what about your social security number? Whoa, we're not on that personal level. I'll give you my quantum numbers. What are quantum numbers? Well, there's N, which is the principal energy level of the particle, and then there's L, which is the angular momentum, ML, which is the magnetic quantum number, and MS, the electron spin, which can be up or down, depending on whichever element is. My personal ones are 2, 1, -1, and +1/2. So those have no correlation with your social security? No. Oh well, better luck next time. Alright, so what else is there? Well, I identify myself as boron, but sometimes I like to wish I was a helium. But my 3 valence electrons really hold me back from that. Really? What's your configuration? Well, it is 1s2 2s2, and 2p1. So the 2s2 and 2p1 are my valence electrons. Alright, so for my Lewis structure, since I have 3 valence electrons, I get 2 dots and another dot. Now for the Lewis structure of myself and my boys' trifluoride, then I got a bond to each one, and then they get their valence electrons around them. For my Vesper, our shape is a trigonal planar, so we make a triangle like so. And the angle for said from one fluorine to the other is 120 degrees, because 120 times 3 is 360 degrees. Alright, I gotta bounce. Peace!